So yesterday we covered shear design and development, right? So maybe one of each. What do you remember? Maybe I can get started. Say for yes.
Shear design because extends depth of concrete section in compression.
Right. Yes. And FRP reinforced beams have smaller shear capacity than steel reinforced. That's because the dowel action is not so good, and then the aggregate interlock is not so good. That's one. Another thing, if you want to remember something, you might want to remember this. The strain limit FFV is 0.004 times EF. That's a big limiting factor. Okay, so that's one. Okay, so anything else you want to add? Anyone else wants to add? Those are, I think, the two most important. In case of development length, splice length, what do you remember?
If beam is fail in development length, then we can increase the number of bars.
Yes, very good point. That's the most important point. If you find out your stress FF from the section analysis, and that is, if that is greater than the developable stress FFE, then we have to make some adjustment. Otherwise, it will just fail by pull out. So what you do is either you increase the length of the bars, number one. Number two, increase the number of bars. Or number three, use FFE as the basis for flexural strain. Perfect. Remember that? That's good. So what about the quiz? So let's go through these points really quickly. No big deal. Dowel action is needed for shear resistance in FRP concrete beams, and it is smaller than that of steel reinforced beams. We already said that. It's true. Shear design in FRP reinforced concrete may be governed by cracking and deflection. That's also true. Yeah. And then embedment length is, if the embedment length is greater than 100 times the diameter of the bar, the developable stress, which is FFE, can no longer keep increasing due to increased embedment length beyond 100 dB. No, that is true, because remember we truncated it. So if you have longer than 100 dB bars, it's of no use. The maximum you can utilize is 100 dB. Okay? So this is also true. So D, does it make sense? Do you want me to explain that, or if you if you go to the figure on some slide 8 or 9 or something like that, it has that one slope 0 to 20 dB, another slope 20 to 100 dB, and at 100 dB it is flat. That's the reason there is no use increasing the development length beyond 100 times dB. Okay. Then next thing, if stress determined from flexural analysis is greater than developable stress for the given embedment length, one of the corrective actions is to increase the number of bars, which is yes, just now we talked about. You are designing a 250 millimeter thick slab. The location modification factor for determining the developable stress for the top bars in this slab design needs to be 1.5. True or false? False. Very good. Because you have to have a concrete thickness below the top bar to be 300 millimeter before you classify that as a top bar. Very good. So that's done. So shear transfer mechanism or shear strength development in FRP reinforced concrete, same as or similar to steel reinforced concrete beams. You have four mechanisms. One is in the uncracked section. You transfer some shear, then by aggregate interlock, and then by dowel action, and then shear reinforcement. Same four mechanisms, no problem. Just that the contribution of concrete in terms of uncracked section, aggregate interlock, and dowel action is much smaller, about 10% or 15% of steel reinforced concrete beams. So that's for the shear strength development. Bond critical design, what is that? We talked about it already, but it's known as bond critical section if FFE is less than FF. That's when you have to consider bond related lengths and stresses. Okay. Now that's done. Now what is the effective depth of a beam? FRP reinforced concrete beam is 400 millimeter. It's subjected to large shear close to the maximum allowed shear. So what is the maximum spacing of the shear reinforcement for detailing? Or D by 4? I thought it was D by 4. D over 4 or D over 3? D over 2. You can see the table. It's probably, I'm sorry, for very large shear. So that will give you the answer. Okay? I can check if you want. D by 4, right? That's what I thought.
0.75.
Yes, that is for regular. Let's just check one time, so I don't mislead you. Yeah, this one here. D over 4. So for very large shear, so closest to the maximum, the very large shear, D over 4. Okay? D over 4 means 400 over 4 is 100 millimeter. Okay? 100. Perfect. So, okay, that's all I think. So that concludes the session on day 4 sessions, like quiz and discussion. So next is Dr. Das will take over. Yes. Yes, I'm listening.
Sir, if my bond strength is less than my FF, and FFE is less than FF,
Yes.
at the time of design, should I have to consider FFE instead of FF?
Yes, that's right.
In all the design
That's exactly right. That's correct. So you have to go back, adjust your stress, make your changes to the movement strength based on FFE instead of FF. Correct.